Hey everyone, welcome to another episode of Black Guy Does Physics, Math Edition. Today we're going to be looking at Systems of Equations, Part 2. Remember, if you have any physics problems you would like this black guy to solve, please comment below. Alrighty then, let's get it cracking. Alright, first things first, we're going to look at the basic definitions that we need to know and the fundamental rule when you're looking at systems of equations. So let's start off with an equal sign. Equal sign. Left side is right side. Left side is right side. Right side is left side. That's what it means. Mathematically, what it means is that anywhere you see the left side of the equation, you could replace it by the right side. That is, you could write the right side. Or if you see the right side, you could replace it by the left side. That means you could write the right side. The fancy terminology for this thing here is you could substitute. That's all it means. You could substitute. That's the fancy terminology. You just substitute. Well, the next one is equation. For an equation, it's anything with an equal sign. You stuff an equal sign in it, it's an equation. It's nothing fancy. It's just an equation. Now, for mathematics, this must be true. The equation has to be true for you to be able to use it in a mathematical sense. That is, I cannot say 2 is equal to 3 because everybody and their mama knows that this is a lie. So you can't write that. But you could, once you have an equal sign, it is an equation. The next terminology is variable. The variable is just anything that is used to represent a number. Your math teachers, they love X's and Y's. Do not understand why they like doing this, but they love it. Now, you could use M, P's, Q's, RT's, triangles, circles, stars, anything you want to use, squiggly lines, anything you want to use to represent a number. There are two things that students usually get mixed up with when they talk about variables. Number one, they think that variables just represent unknown numbers. No, broskies. No, it represents any type of number, known or unknown. Cool. The second thing that students really get mixed up is that they think that a variable means that the number is changing. Nope, that is absolutely wrong. A variable just simply means the number, it is a number. It cannot be multiple numbers, it's just one number. So if I write X, X only has one value. X cannot be 5, 6, 7, 8, 9, and 10. Okay? It has to just be one thing. All right. The next thing is the fundamental rule. And the fundamental rule is that for every unknown, that's the amount of equations you need to solve numerically. Now, what's the difference between solving numerically and solving? It's in the name. Numerically just means that you get a number answer. Solving just means that you get an answer. Solving is using the first thing that we said, that an equal sign is telling you that the left is equal to the right. So for example, if I have X is equals to 5P plus Q, I have now solved for X. Okay? I should write that down somewhere, but I'll write it down in a second. All right, let's look at a little example we have here. A quick example. We see that we have a brand spanking new iPhone 11 Pro Max 64 gigabyte gold. It's $1,099, which is $1,099. If I want to write this out, I could say that. Let's see. We could write that. Let's put this in black. So we could write that one iPhone. Oh, what was that? We could write one phone I is equals to $1,099. Therefore, wherever I see $1,099, it is an iPhone. And if I see one iPhone, it is $1,099. I could replace it by anything. I always go back to my classic example. I've said this before, I'll say it again. If a burger costs $1, is the burger a dollar? Yes, it is. Why is it so? Mathematically speaking, it's so. It doesn't look like a dollar. It doesn't look like a burger. You can't eat the dollar. You can't do anything with it. However, they're equal to each other. That means that they could be substituted for each other. So therefore, if you have $10, you could literally get 10 burgers. You could switch out $10 for 10 burgers. Okay? Cool. All right. Now, let's see if we could find a problem here for our part 2. Let's see what problem we have. Okay, let's write this down. Oh, let's go with black again, I guess. Let's stay with black. So we go 2b. Let's do example 1. We have 2b minus 3a is equals to 13. And 2a plus 2 is equals to 2b. Now, all mathematics is process driven. If you do the process, everything will work its way out. You just trust the process, just follow it through, and you could do. The person I wanted to shout out was Zach. As Zach said, the answer is a consequence of the process, or the answer is a consequence of the procedures. So you just follow the procedures, man. So I'm trying to give you the simplest procedures to get this done. So step 1, what you want to do is that you want to count how many unknowns you have. So we have 1 unknown, 2 unknowns. I don't see any more. Step 2, you want to label how many equations you have. 1 equation, 2 equation. So now I have this, and then I just follow the rule. What's the golden rule? For every unknown, that's the amount of equations you need to solve. Therefore, I have 2 unknowns, 2 equations. That simply means I could solve numerically. Could solve numerically. Ta-da! That simply means I could get an answer, a numerical value for A and a numerical value for B. So what do I do now? Well, I know what an equal sign is. So the next step is that I'm just going to solve for any one of the variables. So I could solve for A in equation 1, B in equation 1, A in equation 2, B in equation 2. Notice here, let me put red around here. Not because this thing is over here, you're going to get confused and be like, oh my God, what is that? Don't worry about it, man. It's just an equation. It's just an equation. Remember, we said an equation is anything with an equal sign. It doesn't have to have all the variables on one side. No, that's not a rule. So don't worry about that. Okay, so what we're going to do, let's solve for A in equation 2. Let's do that. So let's write that down. We're going to solve for A in equation 2. EQN is equation. Okay, so let's see what that happens. So I would move this over. Yep, so that becomes a negative, and then I'll divide by 2. So A should be equals to 2B minus 2 over 2. Everything is over 2, so because everything is over 2, basic, what is this called? Fractions. Because this is all being divided by 2, you have to divide through by 2. So I could write that as, I hate doing that to the side. Don't do that, kids. You write it all the way down. So A would be equal to B minus 1. Because 2 into 2B is B, and 2 into 2 is 1. So the thing I said that you're not supposed to do, I'm going to write it to the side so you could see what I meant. All I did was this. This is for explanatory reasons. Everything is being divided by 2, so you could split them apart like that. Okay? All right, cool. So now I would call this thing equation 3. So now this is what I was talking about. Now you have a solution for A. If we go back to our definition for equal sign, I see that the left is the right. Therefore, A is B minus 1. Therefore, anywhere I see, what could I say? Anywhere I see A, I could put B minus 1. Okay? And then that means I could, what's the fancy word again? Substitute. So I could substitute. So let's see. I am going to substitute A into 1. Equation 1. I'm also going to put a squiggly line through this equation to indicate that I've just used it. I'm done with it. Don't need it no more. Don't want to confuse myself. Okay? All right, let's go get some more space here. And let's see. Let's push this up. And let's see. So I take this thing, U, and I punch you here, because that's where I see A. So now I write 2b minus 3 parentheses b minus 1 is equals to 13. Now I expand that thing, so I multiply through by 3, so that gives me 3b. Negative 3 times positive times negative 1 gives me a positive 3, 13. I group all my like terms, so that would be negative b, I think. Hopefully my math ain't failing me. And this goes over here, so that becomes a negative. So that becomes 13 minus 3. That gives me a 10, negative b. So b is equals to negative 10. Voila! So now we have a numerical value for b. Now that we have a numerical value for b, what do you think you do with it, man? You are going to substitute it. B in, guess what? 3. Because you had a written in terms of b in 3, so I just take the value of b and stuff it where I saw b. Because remember, you just finished with this equation. So you don't go ahead and restuff it back in that. You use the one that you have left. So now I take this and I just right there. Boom. Stuff it right there. So that would give me a is equal to minus 10 minus 1. And we do some quick math. And that gives me minus 11. Awesome. Usually I don't do any more examples because the procedures is laid out. But I think I want to do another one. Let's see if we could do a quick one and see if you could see what the problem is in there. All right, let's do another one. Number 2. It is 2m plus 5n equals to 12, and minus 6n plus x is equals to, is equals to minus 11. Cool. Step 1. I'll give you some time to think about step 1. Step 1. You should be saying it with me now. Step 1, you check how many unknowns you have. 1, 2, 3. Step 2, label your equations. And then you check to see if you have, oh crap, we have 3 unknowns, 2 equations. Can't solve. That's the end of that. That's a, oh man, we can't solve that one. Alrighty, let's try and find one more. And you should understand that the reason why you can't solve is because you have too many unknowns for the equation. So if your teacher tries to trick you like this, don't get tricked, man. You just can't solve. Don't make things up. Okay, let's go with another one. 3p minus 5c is equals to 11, and minus 3c minus 1 is equal to minus p. Okay, let's see what happens here. So, you know what? Let me not make this so a little bit too complicated. Let's take out these negative signs. Let's put a positive p there, and a positive 1 here, and a positive 3c. Let's do that. 3c plus 1 plus p. Let's make it a little bit more simple. Step 1, check how many unknowns. 1 unknown, 2 unknown. Step 2, check how many equations. 1 equation, 2 equation. Oh, so we could solve numerically. And we solve for any one of these. Remember, you just pick one of the unknowns from any one of the equations and solve. That is, you could solve for p in equation 1 or c in equation 1. You could solve for c in equation 2 or p in equation 2. Oh, look at it. For us, we're lucky. We already had solved for p. How do I know I had solved for p? because it said P is equals to 3C plus 1. Got him. So we're ready to go. So all we have to do is just substitute, man. Wow, this is nice. How nice of them. We're going to substitute 2 into 1. 2 meaning P, the value of P into 1, because we know the value of P. P is equals to that stuff. So wherever I see P, I could put 3C plus 1. So I take this and I stuff it here. This one was nice. Refreshing. Huh. So we go 3 times 3C plus 1, close parentheses, minus 5C equals 11. We expand this. What's in the parentheses? 9C plus 3 minus 5C equals to 11. Let's take it a little bit slow so we could group 9C minus 5C equals to, I bring this over here. This becomes a negative sign, so that becomes 11 minus 3. So that gives me, what's 9 minus 5? I think that's 4. 4C, and what's that? 11 minus 3, I think that's 8 if I'm not mistaken. 8, quick math. And C should be equals to 8 divided by 4, which we all know is 2. So now we know the value of, C. So C is 2. So what do I do with that? All I do is that I substitute this into that. Because remember, we found P, so we substitute C into equation 2, and that should be able to give us the value of P. So let's move this up. We substitute P into equation 2. So that gives us, let's see here, we go 3 times 2 plus 1 equals P. So therefore P is equal to 7. Look at that. We're all done. Another mathematical concept explained by your guy, the Black Physics Guy. Great. Well, everyone, we're done. Please like, subscribe, share, tell your friends. Subscribe. Did I mention subscribe? Oh, yes, I did mention subscribe. Make sure you get your alerts, man. I think they go ting, 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 ting. I don't know how they go, but get your alerts. And once again, everyone, kids, remember, don't be a moo-moo.